Hi, this is Andy with Renaissance, and welcome back to another episode of Timing University. For this episode's topic, I'd like to go over what's called clock switching within the PLL. So let's take a look at our PLL. So PLL will have what's called a local oscillator or a crystal or some form of signal generator that this PLL will synchronize to. And usually it's a crystal. Okay. Another feature of our PLL is what we call jitter attenuator, where we can have an input clock. Okay. So if this guy is a bit noisier, right, our PLL will jitter attenuate and then create outputs that will synchronize to this input, removing any jitter for this guy so that the output is very clean. So what happens is, if for whatever reason this clock becomes unstable, if the voltage shrinks or just totally goes away, the PLL is designed to go into what's called holdover mode. Whatever the last good frequency is that it was tracking for this clock input becomes the output, and it'll just hold it steady. But having a system like that isn't very robust. So we'll introduce a second clock. Okay, so having the second clock, if this first clock goes away and we have a way to measure that loss, we can then manually switch to the second clock. So that's called manual switching. We can go into the PLL and say manually switch to the second clock. If the first clock happens to come back, then we can manually switch back. But that takes too long. It's very disruptive to the system. We need something a bit more faster. So the next type of switching is what we call automatic switching. We have a state machine within the PLL which will automatically monitor these clock inputs. So if this clock were to fluctuate in voltage or to just completely go away, then the state machine will detect there's a loss of signal, right? When this loss of signal occurs, it'll automatically switch to the second one, okay? So another type of switching is when we have a priority given to the first clock and the second clock, right? So if the first clock were to come back and the state machine detects that the levels are good, the clock is deemed good, then we'll automatically switch back. That's called revertive switching. So if this were to go away again, it'll automatically come back. And if the second clock were to go away, then it'll just go back into holdover mode. So if you want, you can have additional clock inputs. But for this lesson, we'll just look at two. So during this switch of automatic switching, revertive, if the phase of the first clock and the phase of the second clock is very big, then the output phase will also be affected during that switch. So to help minimize that, we have what's called hitless switching. So whatever the phase is coming in, if the second one is way off, the state machine will try to maintain what that delta is so that any output that is developed from either of these clocks, that phase will get shrunk to a very small delta, so that the phase and the output becomes very small as opposed to having this larger delta here. So that's called hitless switching, where we minimize the phase hit between the clock switches. So hopefully that gives you an idea of what clock switching is. Thank you.